Okay, we're going to do a quick video here on figuring power for a series in a parallel circuit. Power is measured in watts. So let's quick review. We have Ohm's law up here. V equals I times R. We can use that, but the problems on your worksheet are actually problems that you have done previously on the series and parallel circuits, and therefore if you have those right, you can just transfer the numbers over. What I'm going to do is a sample problem here and then let you work on the power problems on the last page of the sheet that I'm going to share with you. So over here I have a series circuit, 30 volts, 3 amps, and my total resistance of 10. So total resistance 10 ohms, total amperage is the 30 volts divided by 10 is 3 amps. I go to my power formulas. My power formula states that power is equal to volts times amps, or I can use I squared R, which is amps squared times resistance, or I can use V squared divided by R, which is volts squared divided by resistance. We'll show you how that works. So first let's find our total power. Our total power says volts times amps. 30 times 3 amps is 90 watts total. That's our total power. Okay? Now we're going to figure the power that is used at each resistor in a series circuit. For that one, I prefer I squared R here, because I know my amperage is consistent here. Okay? I have 3 amps. Well, if I squared is 3 squared, that's 9. My resistance is 6. 9 times 6, if my math is right, is 54 watts used at this resistor. All right, now, if I know my total wattage, and I know the watts used here, I can find my second one by simple subtraction. 90 minus 54 would give me 36. But for the math of it, there's the power 1. Power 2, I do the same thing. I squared times resistance. My I is constant, it is 3, squared, it is 9, times my resistance 4 is 36 watts. If I take 54 and 36, it comes up to 90. My wattage lost, used at each of these resistors, adds up to the total wattage at the beginning. Okay? So again, we're going to use power for the total power. We know my voltage and my amperage, we figured that out. We multiply those together and we get 90 watts total. Then we use the second formula, I squared R, to find how much wattage we used at each resistor in the series circuit. Okay? That's a series example. Here is an example in a parallel circuit. Okay? Hopefully this doesn't look too crazy over here. But 24 volts, 6 ohms, 8 ohms resistance. Let's go through and I figured out the amperage for each branch of this circuit, okay? So we go back to Ohm's law, V equals I times R, right here. Well, I know my voltage of 24, okay? And I know my resistance of 6. 24 equals I times 6. I don't know my amperage for this branch, but I can figure it out simply by dividing 6 on each side. 24 divided by 6 is 4, so for this branch and this branch alone, I have 4 amps. Okay? Simple voltage divided by my resistance. Well, let's do the same thing over here. Voltage, 24, divided by 8 is 3, so I have 3 amps going in this circuit for a total of 7 amps. All right? Now, let's use our power formula. Power equals volts times watts. Power equals volts times watts right here. My power total would be 24 times 7, which equals 168 watts. I've written that here and here. That is our total wattage. Now, let's figure it out for each branch of this parallel circuit. If I use my I squared R, I use the amperage for this branch, not the total. Okay? I have 4 amps here. I square that to get 16. I multiply it times the 6 ohms and I get 96 watts right there. Okay? Now again, if If I know that I have 168 total watts, I can simply subtract this, but for the practice of doing the math, let's take a look at our last branch here, our second branch. We have an amperage of 3 amps here. I squared times R is how we do it. 3 squared is 9, 9 times 8 is 72. Okay, that's for this branch of the circuit right here. We take 96, add to 72, we do indeed get 168, so our wattage here being used equals our wattage at the start. And that is a very quick, down and dirty a look at the power, figuring power in a series and a parallel circuit. So you can use this to solve the problems that will be for power on the little quiz I gave you. All right, any questions, you can give me a holler. Thanks, bye.